In this example, we are going to determine the truth value of the following statement, okay? If P is false and assuming Q is true. Okay, so the first thing that I'm going to do is I'm just going to write a little F below the P so I remember that that statement is false. And I'm going to write a little T below the Q so I remember that statement is true. And then just like we do in algebra, I'm going to work from inside the parentheses and then work outwards. The first thing I see here is I see the negation in front of the P. So not P is a true statement. Okay, and then I have a conjunction here with the true Q. So I'm just going to bring that down, and then over on this side, I'm going to work on this disjunction. False or true is a true statement. Okay, so now I'm going to work inside this parenthesis. A conjunction where I have two true statements is also true. And now I have a disjunction here of two true statements, or sorry, the negation of this true statement is false, and then disjunction true, and a disjunction where one statement is false and one is true is also true. So the truth value of this statement is true if I assume P is false and Q is true. In the second example here, we are going to construct a truth table for this statement, and I'm going to show you two methods for doing that. So method one is sort of the brute force method, okay, and since this statement involves only two things, P and Q, I'm going to start by making my table with the following two columns. P could be true, true, false, false. And Q, I have true, false, true, false. So for a statement that has two statements, P and Q, you're always going to start your truth table like this. And then I'm going to, the next thing I'm going to do is I'm going to make a column for not P. Okay, and that's just the negation of this column. So that's going to be false, false, true, true. So I'm just looking at these values. And then I'm going to make a column for this, the part that's in the parentheses. So P and, not P and Q. So I will be looking at these two, the conjunction of these two columns. And we know that a conjunction, true and false, will give me false. False and false, false. Conjunction true and true is true, and a conjunction with a false and a true is false. Okay. Next, I'm going to take the negation of this statement. So we have the negation of P, conjunction Q, P and Q. And so I'm just going to be negating this statement, right? So I'm going to look at false, false, true, false will become true, true, false, true. So we're just negating this column. And I'm going to finish it off with this disjunction. So let me write everything out. So in order to find the truth value of this guy, I will be looking at the disjunction of this column with these values over here. So true, true, the disjunction is true. False, true, we know the disjunction is true. True, false, this is true. And a false and a true, the disjunction is true. So all the statements are actually true. The statement is true for any pair of truth values. And when that happens, we call this a tautology. So this statement up here is a tautology. So let's do the same example. We're going to construct a truth table again for this same statement, but we're going to use method 2, which I would say is more of a shortcut. So let me show you how to do that. So I'm going to start with the same two columns that we always start with for a compound statement with two simple statements. True, true, false, false, true, false, true, false. Now instead of writing just writing the statement piece by piece, I'm going to write the whole statement here. So the negation of P, conjunction Q, and or disjunction Q. So I write the whole statement. I give myself plenty of space. Now the first thing I'm going to do is anywhere that I see P, Q, or not P or not Q, I'm just going to replace those with the appropriate values based off of the values over here on the left. So not P would, since P is true, true, false, false, not P, the negation of P would be false, false, true, true. And Q, I'm just going to copy, would just be true, false, true, false. Now, I'm always looking inside the parentheses first. Okay, so the next thing I'm going to look at is this conjunction right here, and that will finish off what's inside the parentheses. So we know what the conjunction, a false and a true, is false. A false and a false is false. True and true is true, and a true and a false statement is false in the conjunction land. Okay, so we've basically finished off what's inside the parentheses. Now I'm going to work on this negation that's outside of the parentheses, and all I have to do is negate this column here. So false, false, true, true is going to become true, true, false, true. So now I just have to deal with the disjunction, and the disjunction, I'm just going to be looking at the values in this column right here, and this expression on the other side of the disjunction. So if I look at these guys, we know the disjunction of a true and a true is true. True and false is true. False and true is true. And true and false is also true. And this is the final value. True, 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 which is what we got last time. So remember, that tells us this statement is a tautology. It's always true. It doesn't matter what P is. It doesn't matter what Q is. This statement is always going to be true. It is a tautology. Here's one last example for you. It says use De Morgan's law to rewrite the following statement. So it is not true that I ate dinner and I ate dessert. So I'm going to rewrite this. I'm just going to call this P, and I'm going to call this Q, and I'm just going to write this symbolically so you can understand what the statement is saying symbolically. So it is not true that. So that's a negation of, and then we have a comma. Okay, so that's important. And then these statements, I ate dinner and I ate dessert. So that's essentially what the statement is saying in symbolic form. De Morgan's law tells us that this conjunction is equal to the disjunction of not P or not Q. And if you think about it, that makes sense, right? So if it's not true that I ate dinner and I ate dessert, then in that case, that's like saying either I didn't eat dinner or I didn't eat dessert, right? So one of those things didn't happen. If they didn't both happen, then one of the things didn't happen individually. So let's rewrite it in this format. So I would write this as I did not eat dinner, or I did not eat dessert. Okay, and then that would be the equivalent statement using De Morgan's law.